Hi, everybody. So I just want to make sure that you get your homework complete for chapter 4. It is due. So for the first problem in your homework, you have an exponential. So you are just taking the x value as your power. So 3 to the negative 2, 3 to the negative 1, 3 to the 0 power, 3 to the first, and 3 to the second. And then you just have to use the graphing tool to graph those points on the exponential. And then you have your next problem. So it'll be some form of this. So it'll be a base taken to an expression, x plus 4. And then almost every problem has the same kind of asymptote. So you're just shifting the graph of 2 to the x to the left by 4. And then you have your asymptote at y equals 0. The domain, pretty standard. And then also to plot your points, you can just use a table again. And then for this one, it's just a special exponential using e. And, e is a special function. So you just use your example to figure out where your y-intercept is. It's just going to be shifted down to around where it says negative 4. And then that's where also your asymptote is. Then your domain is the same, and then your range begins at negative 4 to infinity. And then for this one, you're just going to use the example as what to model this by. So suppose you have $11,000 to invest, which of the two rates would yield the larger amount in 5 years. You have 11% compounded quarterly, or 10.92% compounded continuously. So you use the formula A equals P times R, 1 plus R over N to the NT. And then you just figure out what all of your numbers, where they go. And then you use also A equals P E to the RT. So that one is for continuously. And then your years are 5. Your R for compounded quarterly is 11%, so you just change that to a decimal. And then for the other one, it's 10.92. So I made a little mistake there, so you can just put in your 0.109. It's not that big of a difference. It kind of rounds to 11, but and so you just substitute your numbers in for the letters. So just use the example for this one to finish. You just plug the numbers in. And I made a little mistake where R is equal to 0.10. It should be 0.1092. And yes, use all those decimal places. So just be a little bit careful about that one. And then the next one, number 5, the function f of x equals 80e to the minus 4x plus 20 describes a percentage f of x that a particular person remembers. So here, all you need to do is just use the example. You're just substituting numbers in. So you're substituting 0 in for part A. You're substituting 1 in after 1 week for part B. You're substituting 16 in for x in part C. And then it says after 1 year, there's 52 weeks. So you just substitute 52 in. And then you just use the calculator to figure out what you get after that amount of time. And then for number 7, you are just answering questions. You're filling in the blanks. So the value 1 plus 1 over n to the n approaches as n gets larger, and larger is an irrational number. That rational number is e. And then part 2, it is a natural base. This irrational number is equal to 2.72. So you can just put that into a calculator and figure out what e is equal to. Okay, and the same thing for number 8. You just grab him from the multiple choice, your choices here. You're just picking apart, the formula. So it's pretty much straightforward there. And then remember, you're using the definition of a logarithm here. So x equals b to the y. So you just make the adjustment and put the things in the proper place. This one, you have to think to yourself, what do you take 11 to get 121? And that's 11 to the second power. And then you're just graphing the exponential and then the logarithm, which is the inverse. So you just use Desmos for that. You use Desmos for the next one. Again, the same thing. And you can kind of tell based on your experience with exponentials and logarithmic graphs. And then you're just going to use the multiple choice here. So just use the example. It cut off a little bit where it says how it shifted, but it shifted up by 2. So the regular graph of the logarithmic function, it has a vertical asymptote. And then you just, use the example and Desmos to verify. And then you have the domain that has a restriction. You can't have negatives. And then the range. And then for 14, you're just going to set what's in the parentheses greater than 0, and you're just going to solve for x. So the domain is all of the x's that are greater than 3. And then, of course, from the properties, you know that the ln of 1 is 0. And then for the next one, it's best to just use the example here. So you see what the bar graph gives, and then you see the scenario. So we're going to just calculate the number of years from 2000 to 2019, sorry. And then if you look here at the example, the numbers are exactly the same, just about. You might get a little bit different result based on your number, but you just use the example to figure out your first value, part A, and then your second value. And you can see on the actual document, once you use the example, what you get. And then we have the properties of logarithms. So these are multiplied, so we separate them. Remember, the log base 3 of 3 is 1. And the same thing, well, you use the properties of logarithms to do 18. So we have a fraction, so we just separate with subtraction. And in this one, we have the 10th root of, the ln of the 10th root of x. So it's just a fractional exponent. And then you use the properties to just bring that exponent down. And likewise, we're just going to use the properties of logarithms to separate these. So we have division. So we subtract. And then we have log base 2 of 8. So 2 to the third equals 8. So that leaves us with the 3. And then the rest, you just use your properties. And then on to the next one. So we have multiplication, we have an exponent, and we have division. So just separate accordingly. All right, so now you just do the same thing, even if you have a number and you have a variable, but you just, use the properties accordingly. And then for 23, you have a lot going on, but you just separate them first. And then you just apply the power property for logarithms. And we'll let you finish the rest. You just have to apply the power rule for logarithms. And then for the next one, it is rather long, but give yourself a little challenge. And then for the next one, now we are condensing. So you see addition, so you know we need to multiply. So we just bring those two, x and 13, together. And again, you see addition. You also see a number in front of the log, so you know that is a power. But that only goes to z, so be careful. And that word is property. And then, of course, we have subtraction, we have the powers. So you see how we end up with that result. And then, of course, 29 looks like a lot, but, you can see that it's just, you just take it step by step. And then in number 30, you are just determining if the statement is true or false. So if it's false, just write the correct statement. And then the same thing in 31. And then next, you just have a problem where you're summing up the rules for logarithms. So this is the product rule. So you know what to do when you see a sum. You are going to, when you use the product rule, you're going to do the sum. The same thing for when you have the quotient rule. You're dividing, but then you subtract, which is the difference. then the power rule. It's just summing up the properties. Then you have the change of base property. And then for 36, what? So 2 to the what equals 8, and then 7 to the what equals 49. And then in 38, you have an exponential equation. So the first thing that you do is you're going to divide both sides by 7. And then you're going to take the ln of both sides. And then the ln of e, of course, will disappear. So you cross it out and you get your result. And then you just put all of that in the calculator. So the ln of 89 divided by 7. And then for this one, you need to subtract 4 from both sides. So 4 plus 6 ln x equals 3. And then you get 6 ln x equals -1. Divide both sides by 6. And then you have to do the opposite of what you did before, e to the ln of x. And you have to raise both sides in the same as you did the ln of both sides. And then x equals e to the -1/6, and then you just put that in a calculator. And then for 40, we're just going to use the example. So all you're going to do is use the product rule. You're going to condense. And then once you have both sides condensed, you can eliminate the logarithm and just set each side equal to each other. Solve like a regular equation, but you can already tell that you're going to get something that's negative, which leaves no solution. And then finally, the last problem, we're going to use the example. So you see that you just plug in 0 because it corresponds to the year 2003. problem. It's an exponential growth model. We're just also going to use the example. It's much neater than my handwriting. And then you just figure you're going to use, taking the natural log of both sides eventually to figure out what your value is for K. And then once you find your value for K, you're going to use that, substitute it in, and then you're going to find your value for T. So you'll end up with adding the number of years to the original number that you started with year. And in this, you have the year 2000. So you just add 90 to it, and you end up with your result. And as always, thank you for watching. See you next time.